So in today's homework we're going to be looking at numbers written in base 2. Now this is slightly different from the numbers you're used to using because you're used to using numbers written in base 10. So if we take for example the number 321, that's the type of number you would see all the time, and it's basically split into columns. You can imagine that this number is actually made up of 3 different columns, and each column is worth 10 times more than the previous column. So the first column are your ones, okay? Quite often we call them units. Your second column are the tens, and the third column are the hundreds, and you keep on going like this, so the next column will be the thousands, then 10,000s, and so on. Each column is worth 10 times as much as the previous column. Now, in base 2, it's slightly different. In base 10, our normal numbers, we're using 10 times the normal columns. In base 2, everything is 2 times the previous column. So, if we can imagine our first column is still ones, our second column, though, instead of being tens, is going to be twos. Our third column, instead of being hundreds, is 2 times as much as the previous column, so it's going to be fours. And our third column, our fourth column, sorry, is going to be twice as much as the third column, which is eights. So, a number written in binary in base 2 doesn't have as many digits as base 10. In base 10 we have 10 digits. We have 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. In base 2 we only have 2 digits, so we just have 0 and 1. So if I was to write a number in binary, it would look something like this: 1, 0, 1, 1. And I can't go any higher than that. I can't have 2s and 3s and 4s. I can only use the digits 0 and 1. Now if I think about that number in terms of its equivalence to our normal counting system, this number has 1, 1, 1, 2, no 4s and 1, 8 in it. So we can think about that as adding together. We can think about that as being 8 plus 2 plus 1, which in our usual, more normal counting system would be worth 11. Okay? 1, 0, 1, 1 in binary is worth 11 in our decimal counting system. Let's have a look at a couple more examples. So how about the number 101? Well, that number has 1, 1, it has no 2s, and it has 1, 4. So in our normal decimal numbers, that would be worth 5. How about the number 1, 1, 0, 1? Well, that has 1, 1, no 2s, 1, 4, and 1, 8. Add those together, you get 13. So, by writing out numbers like this, we can convert any binary number, any base 2 number, into one of our more normal decimal numbers in base 10, just by thinking about what the columns are worth. So on the next page there are going to be 5 binary numbers, and I'd like you to convert them all into decimal numbers. So have a go at working out what these numbers are in base 10, in our normal decimal numbers. Okay, over the page is another question for you to have a go at. What I'd like you to do is to think about how you would add 2 numbers in decimal form. So there's an example on the page here: 32 plus 29. You would do 2 plus 9, which is 11, write down the 1 unit and carry the 10 into the next column. 3 plus 2 is 5, plus the 10 that you carried is 6. So the answer is 61. Try and figure out how you would do the same thing, for adding two binary numbers. Okay, it's very, very similar. That's what I'd like you to have a go at, ready for the next lesson.